ASR features are generally used to mitigate unintended voice assistant activations. Full-scale ASR models run on server requiring the user audio to leave device, thus it can cause privacy concerns. We show that the voice trigger detection and false trigger mitigation are extremes of the same task. We propose a unified and hardware-efficient system to handle both the tasks progressively without any dependence on the ASR features. We first briefly show the on-device voice trigger detection architecture. The first stage is an always-on low-footprint model which processes continuous audio stream. The second stage uses a larger capacity model to analyze the candidate trigger segments sent by the first stage. Second stage can still get activated if the trigger segment is acoustically similar to the keyword of interest. FTM systems analyzes the post-trigger audio to mitigate such queries by using ASR features which require the unintended audio to leave user device. There has been some work which shows that the post-trigger acoustic features have discriminating information to determine user intent. We propose a unified voice trigger detection and FTM system which share the compute between both the tasks and uses only the acoustic features. We build on top of our previous work of transformer encoder to jointly optimize for both the tasks. We add streaming self-attention layers in the transformer encoder to process incoming audio in clockwise manner with some shared left context. We also use an attention mask to simulate streaming behavior during training to avoid slowdown. Additionally, we use cross-entropy loss and LSTM on top of the encoder for the FTM task. We train the system similar to ASR acoustic models, where the phonetic branch is trained to generate the phonetic transcription of audio, and the phrase discrimination branch is trained to generate frame-level probability indicating user intent. For voice trigger detection, we evaluate the system on two of our internal evaluation sets. On both the sets, the proposed system improves upon the baseline false reject rate by relative 18%. For FTM task, we analyze the impact of increase in post-trigger audio on false trigger rate. Not only the proposed system is able to mitigate higher number of unintended false trigger activations, we are also able to improve upon the baseline by relative 40%. In on-device inference metrics, the proposed system is able to reuse the computations to have linear runtime complexity as input audio duration increases due to its streaming nature. In summary, we have proposed a unified streaming on-device solution for voice trigger detection and false trigger mitigation. The unified model is able to improve FRR by 18% relative and also able to mitigate up to 95% of unintended false triggers with just 1 second of post-trigger audio. It also reduces the on-device runtime memory by 32% and inference time by 56%. And most importantly, we are removing dependence on ASR systems, which make the system privacy preserving. Thank you.